In this video, we're going to be talking about some other operations that you can do with images, including swapping layers, changing the brightness, creating negatives in images, and also grayscaling images. So when you're swapping layers in an image, what you're doing is you're changing around the values that are on the red, green, and blue and making new colors. So your image is going to look different or different color combinations. So for instance, let's say, let's be an artist again. Let's say I had a picture and let's say there was like some grass down here. And let's say there was the sky. Okay, beautiful. And then let's say there was a nice red ball in the center. Wow, beautiful. Okay, so let's say I had this picture. And let's actually draw out kind of what each of the layers would look like in order to create these corresponding colors. So let's say I had my red layer, my green layer, and my blue layer. Blue. Right? So everywhere where the sky is, right, where it's blue, that's when I have red is 0, green is 0, and blue is 255. So let's go ahead and just do that. So like all up here, 0, 0, 0, 0, 0, 0. My green, 0, 0, 0, 0, 0, 0, 0, 0, 0. And my blue, these are all 255s. 255. I'm lazy, so I'm not going to write out as many 255s, but hopefully you understand. Okay, and so the reds, right, the red, or the red ball, and that location, the red layer will be 255, so 255, 255. My green will be 0 still, so there'll be some zeros here. And my blue will also be zeros, so zeros, zeros, let's do zeros. Let's do it like that, so 255, let's do like 4. Oops, 255, okay? And then where my grass is, that means my red is 0, 0, 0, 0, 0. My green is 255, so 255, 255, 255, sure. And my blue is also all zeros, so 0, 0, 0, 0. All of these up here are zeros, okay? So that's what each of these layers looks like. And if I did some line of code to swap these layers, so if I said new image is my old image, let's say I want all of the rows, all of the columns, and my layers, let's say I index it such that my first layer was actually my third, my second is my first, and my third is my second. So what am I doing here? So I'm essentially swapping all of these layers around. So let's rearrange this. So actually let's write these in a different color. So let's write these in red. So 3, 1, 2. So what's happening there is in this case here, my first layer becomes what my last layer was, right? So therefore, this third one becomes my new red, all right? And the second one is what my first one was. So this becomes my new green. And lastly, this becomes my new blue. So if we try to redraw what this picture will look like, let's look at what the sky will be. So in the sky area there, our values, right, will be 255 in the red and 0 everywhere else. Okay, so therefore now we have oh my gosh, a blood sky. The apocalypse is coming, right? And then if we look at where our grass was, right, that means that so that's kind of at the bottom there. Let me change this back to white. That's where our blues are now 255, right? So our greens are 0 and our reds are 0 and our blues 255. So that means we have blue grass. I like the music, but our grass is blue. Okay. And then if we look at where the ball is now, that's where our 255s are in our green, and it's 0 everywhere else. So therefore our ball is going to turn into green. Oh man, okay. So this is what our new picture would look like by swapping our layers. So swapping the layers, it keeps all the values in their same spots, but in terms of interpreting colors, our colors will change because we're moving the values around. And so our final image will look different than our original one. All right, so in this example, I want to take this original Serena image, right? So we have this, and we want to swap some of the layers and see what happens. So if I take this original image and I say new image is my old image with all my rows, all my columns, but now I want to index my layers a little bit differently. So I want the third layer first, then the first layer, then the second one. And if I were to show this, so let's do figure IM show new image, right? If we were to do this, now we have, this is our original image, and this is our new image, right? So we swap the colors. And so does this make sense? Do these new colors make sense? Let's concentrate just on the ball here, right? So our ball is yellow, and it changed to this cyan color, right? This teal, like light blue color. And so does that make sense, right? So the ball originally, so if we just look at in terms of red, green, and blue, the ball originally was yellow, so that means our red was 255, our green was 255, and our blue was 0. And in our code, we are swapping it such that our third layer comes first, so therefore we're putting a 0. Our first layer comes next, which is 255, and then our second layer comes next, right? So this is around what that color will be. And what we have here is where our red is 0 and our green and blue are 255, that's cyan. So that makes sense in terms of our colors. So swapping the layers will swap around the values in your image, which will change the colors. The overall structure of the image will stay the same, but the colors will become different. So let's talk about changing brightness, right? So if the largest value that our images can have is 255 and the lowest is 0, right? If we start adding or multiplying our images by some positive numbers, they're going to get closer or going to get higher to 255. And so if 255 is like our maximum intensity, right, that means that our picture will become brighter. And if we start decreasing those values, either like dividing or subtracting numbers, our image is going to get darker. So if I wanted to create an image that was twice as bright as the original one, so let's call it like, oh, I don't know why this is green, but that's fine. Let's call it like bright 2. We can take our image and just multiply it by 2. This is going to multiply every value in all of the layers by 2, so therefore it's going to double the overall intensity of our image. If we wanted to make it darker by a factor of 2, right, we can take our image and divide it by 2, right? This is going to bring all the values down closer to 0, right? So in this case here, it's going to be darker. And so, and I can also do this by like adding or subtracting as well, but by changing the values to be larger or smaller, I'm changing the overall brightness of my image. All right, so let's change the brightness of our Serena image, right? So we have, once again, this is our, let's do close all. Oh, I can't type, close all. And so we originally have this Serena picture here, right? And then now we want to change the brightness. Let's say I want to make it twice as bright and then also half as bright. So in order to change it to be twice as bright, so let's say new image 1, I'll take my old image and multiply by 2. And let's do figure IM show new image 1. And then if I want to make it half as bright, so let's call it new image 2, let's go ahead and divide by 2 and figure IM show new image 2. So let's go ahead and run this. Oh, let's suppress everything as well. Let's go ahead and run this. And as you can see, where's my original? So this is my original. This is it twice as bright, and this is it half as bright, right? So twice as dark, right? And so notice here you can see that our pictures got closer to, or values got closer to 255 in this second one and closer to 0 in this third one, which changes the overall brightness of our image. Creating the negative of an image, the easiest way to think about this is if I had a pure black pixel, that means that I would want to change it to be white. And if I had a pure white pixel, I would want to change it to be black. So then we need to think about, how can I do that? How can I do that like mathematically? And then keeping in mind that everywhere, everything in between needs to be changing into the negative as well. And to do that, the formula is, I would say my negative image will be 255 minus my original image, right? So let's see like what this is doing here. So this is going to subtract 255 from all the values in all of the layers. And so what this is doing is let's say I had a pure black pixel. If I had a pure black pixel, that means I would be doing 255, and then minus my red value, which would be 0, my green value, which would be 0, my blue value, which would be 0. So therefore, all of these will change to be 255, 255, 255, right? And if I had a pure white pixel before, I guess I'll draw this up here, right? That's when the red, the green, and the blue are all 255. These will all change to 0. Okay? So this is like my red value, my green value, my blue value, my red value, my green value, my blue value. Okay, and so this works for like black and white pixels, and then it'll change all the intermediate values as well, the intermediate colors. And so let's think about what if I had like a pure blue pixel, right? If I had a pure blue pixel and I did this, that would be 255 minus where RGB, where my red is 0. My green is 250, oh my gosh, not my green. My green is 0, and my blue is 255, right? So if I do the negative of a pure blue pixel, I get back 255, 255, 0, right? So in this case here, this is a yellow pixel. So the negative of blue is yellow. And so this simple formula here will create the negative of your image. So let's go ahead and take the negative of our Serena image. So once again, we have this original Serena image here, and we're going to take the negative of it. So our formula here is, let's call it negative image is 255 minus my original image. Okay, so let's do a figure, and I am show neg image. Let's go ahead and close all, CLC clear. Oh, CLC. So if I were to run this, boom. Right, so my original image here and the negative of my image, oh no, and the negative of my image over here. And so like we said in the previous slide, right, the negative of yellow is blue, right? And so that's why that happened there. And as you can see back here, there's like these black pixels, and all of those changed to white, and all these white pixels had changed to black. Okay, and so a common mistake that people have is, does this also work if I flip this, right? What if I did image minus 255? Okay, if I did this, what's going to happen here, let's close all CLC. So if I did this and I ran it, oh, I get an entirely black image, right? And so this makes sense because at max, these values here are 255. So if I'm subtracting 255 from everything, everything will go to 0. So everything will be black, which is not the negative of my image. So when I grayscale an image, I'm essentially taking all of the colors and changing them into different shades of gray. And the shade of gray that I change it to is representative of the original intensity of the color. So that means that if I had a more intense color, meaning that it had more contributions of the red, green, and blue, then in my grayscale image, that's going to be closer to white. And if I had a less intense, right, then in my grayscale image, that part is going to be closer to black. And so first, talking about gray, gray in a computer is when the red, green, and blue values are all the same. So therefore, black is the darkest shade of gray, and white is the lightest shade of gray. And so in order to think about these intensity values, a lot of the times we like to just assign an intensity value for a pixel to be like the average of the red, green, and blue. Okay, and so let's think about this. So if I had, let's say I had a picture that was just 2 pixels. Okay, so 2 pixels where the left is pure white, okay, and the right was pure red. All right, so if we were to draw out like the red, green, and blue for each of these, red, green, and blue, for the white, it's 255, 255, 255. And for the red, it's 255, 0, 0. Okay? And so if we were to grayscale this, right, we would assume that the pixel on the left-hand side will be brighter than the pixel on the right-hand side because it has more contributions of the red, green, and blue, right? And the one on the right will be less because it has less contributions of the red, green, and blue. And so like I said, we figure out this intensity by taking the average of our layers. And so let's go ahead and try to write some code in order to do this. So first let's separate our image into its layers. So my red will be my image 1, green will be my image 2 at the second layer, that's a 2, and my blue will be my image at the third layer. Okay, and so now if I want to create this average value, I can just add up the red, green, and blue and divide by 3. So let's say my average is my red plus my green plus my blue divided by 3. Awesome. And so now this is just one layer, right? And if I want to make this a gray image, I have to go and stack these on top of each other because I want every single value at a specific pixel to be the same, right? Because that's how I create a gray pixel. So this will be an array of different values, right? But when I stack them on top of each other at one particular point, the red, green, and blue will all be the same. So let's go ahead and call this a gray image. Okay, and this will be the cat 3 of my average, my average, my average. All right, so let's look at this code and see what's going to happen here. Okay, so we have our red, green, and blue separated, and then we're going to add up our red, green, and blue and divide by 3. If we were to do this, we have to remember that the class of R, G, and B, these are uint 8, right? These are uint 8, okay? And our uint 8 values are capped off at 0 and 255. So therefore, in this case here, if I was looking for the average, right? So let's say the average. If I did 255 plus 255 plus 255 with uint 8 math, that is 255, okay? Because I can't go over it. And so therefore, when I divide that by 3, I get back 85. All right, and then on this right-hand side, or the right pixel, I have 255 plus 0, which is 255, and then divide that by 3, that's also 85. So in this case here, my average value, my intensity value, is the same for the left and the right. So when I grayscale this, my pixel on the left will be the exact same gray as the pixel on the right, and that's not correct, right? And that's because we have this bound of our uint 8 values, right? We technically want that addition to go over the limit of 255. And then when we divide it, it'll come back into our range. But we have to give it freedom to go over. In order to do that, we have to first change our values to not be uint 8 anymore. They have to be doubles. They have to be able to go over that 255. So there's different ways that I can do this, but let's say at the beginning of my code, just to make myself have less writing, let's say at the beginning of my code, I went ahead and I casted with the double function my image after I had read it in. So now my red, green, and blue are no longer uint 8. They are class double. So then now when I do my math, I'll have 255 plus 255 plus 255. And then when I divide that by 3, now this left-hand side, actually I'll just keep that, I'll cross it out. This left-hand side will become 255. And then my right-hand side will stay as 85. But then now what will happen is that my left pixel will be all 255 for red, green, and blue, right? So that's pure white. And my right pixel will be all 85 for red, green, and blue. So that'll be a darker shade, or that'll be a darker shade of gray. And we just have to remember as well, right? So we casted these to doubles. So if we actually want an image, we want to make sure that our image is class uint8. So before I finish my code, I need to cast my gray image back to uint8. So I don't have room, so I'm just going to draw an arrow that goes up here. So therefore, my final gray image, I'll use uint8, so that function uint8, in order to cast my gray image back to that class. And so that's how you grayscale things in MATLAB. So let's go ahead and do the grayscale of our Serena image. So the first thing we need to do, like we said, is we need to convert our image to double. So let's say image is the double of image. Now let's go ahead and separate our image into layers. So we have red is image first layer, green is our image at the second layer, and blue is the image at our third layer. Oops, third layer. Oh, I can't type. Third layer. Okay, so then now we want to find the average, right? And so that's going to be our red plus our green plus our blue divided by 3. And then now that we have this average array, right? So this is an array of just one layer. Every index will be some different average value. We need to create this gray image. And that's by stacking this layer on top of each other, on top of itself 3 times. So let's go ahead and say gray image. So that'll be the cat3 of average, average, average. And so we have to remember that we need to convert this back to uint8 in order to make it an actual image. So let's say gray image is uint8, oh, not 7, uint8 of gray image. And then let's go ahead and show this. So I am show gray image. And so let's see what this looks like. Boom, right? So we have our original image here, and we have our grayscaled image, right? Looks pretty cool there, right? So we can see that elements that are closer to white, right, or lighter shades of gray were more intense in the original image, right? And locations that are darker shades of gray were less intense. And so just once again, the importance of changing this to double, right? What if we didn't change it to double? What if we try to do the average without changing it to double? So let's, right, so we have, this is our original image, or this is our grayscale image now. And so if I were to do this again, right, so now this is our grayscaled, okay? And so this isn't correct, right? So notice like how it's a little bit muddy. This is because everything is being capped off at 255, which means that colors that are actually different in intensities end up being shown as the same intensities. Notice, however, you can still tell, you can still see the form of Serena because there are places that have like higher contrast, right? Such that you can see different edges and stuff like that. But the fine details have gone away because things that were things that kind of got smushed into the same category of intensities actually weren't, and it makes the image look muddy. So you have to remember to change all of your values to double first.